Hi guys, hope you are all doing great. So today we are going to look at one of the topics in logarithms and indices. And we said that the two topics specifically which I've mentioned have a specific relationship which we're going to see being developed as we go by in these different topics of under laws of logarithms and indices. And from this, of course, we said that basically the concept of indices we can generally define the concept of indices as, of course, uh, in different ways. And this case is going to be just specifically applying to our discussions on these specific topics in mathematics and sciences. We're going to see that in commerce and other areas, this is going to have a different implication. But for our case, specifically in mathematics and sciences, this is going to refer to the power or exponent which is raised exponents which of course is raised to a number or a variable. A number or a particular variable. So in this case, it is just a general definition for the term indices. And that basically is a plural of the word index. Now suppose we have a number like 2 raised to power 3. Then this one can be represented using, or maybe we can use this one to define the concept of an index, or index, which basically, this is the plural of the word index. So basically, in trying to define the term indices, then we're going to see that this is a power or an exponent which is raised to a number. So therefore, in this case, the number 3 there represents what we call our index. And whenever they are a range of numbers, then therefore we're going to refer to them as indices. So having said that one, then we're going to look at some of the laws which are applicable insofar as these numbers which have been raised to indices are concerned. And therefore those are what we refer to as laws of indices. So this basically refers to the ways in which we're going to treat a different, of course, a division or operations for division, multiplication, addition, etc. of these different numbers which have been raised to specific powers. So for the first one, we're going to see that whenever we have a number that is just similar, like a raised to 2 different exponents, then that one dictates that the result of the product of those numbers is going to be a with that exponent being a sum of the 2 individual index or indices that we are seeing in this particular case. So from this, of course, they can be of different forms, but this is our first case for this law of indices. Dictates that whenever we're having a number a raised to an exponent with a similar product of a number a raised to a different exponents, then we're going to have a sum of that. And even if it's the same, still we're going to see that that is going to be applicable. But in this case, I've just given it a different exponent in order to make a difference. So in this case, number 2, we're going to see that whenever we're having exponents which are, of course, having a division, of course, over the same number, and we're going to represent this one using a raised to the difference between those 2 specific exponents given as such. And then number 3, we are going to see that whenever we have sorry for that, a number a which has been raised to a particular power or index, then we're going to have an index which is a repetitive, then therefore implying that this is a product of an exponent. Then therefore this number is going to be represented as a with the product of those 2 specific exponents given as such. And then number 4, we're going to see that whenever we have a number or a product of 2 numbers which have been raised to an exponent, and therefore this is going to be distributive in a way that we have n a raised to n and b raised to n as a product. And then number 5, I hope this one is elaborate, so we're going to just have a continuation of this so that we can mention other laws which are going to be applicable. So number 5, we're going to have a rational number a over b which has been raised to m. This is going to have the same property for the distributive aspect that I had said. So it's going to be a over m b raised to m. So for that, so this a exponent m, b raised to m, and therefore we're going to have another one which is 6, which basically, if we have the same fraction, or rather the same rational number which has been raised to an m. Of course, for the normal numbers in one of our videos, we had said that this is an inverse multiplicative property. So therefore, we're going to have this one represented as a negative m over b negative m. Now, since we said that we can be able to represent a number a negative 1 as 1 over a, we're also going to extend this property and try to give it in another format whereby we are going to have bm over am being part of that specific law of indices. So number 7, we're going to have this one, another form for this one represented as a negative n over b negative m represented as bm over am, just analogous to the previous one that we have discussed. So from number 1 to number 7, these are some of the applicable laws that we're going to discuss whenever we're going to tackle the concept of our laws of indices, and they're going to be applied in different areas that require the operation which is going to involve the concept of indices. I hope that this one, of course, we have understood. And these specific laws are used to, of course, evaluate and simplify or solve exponential expressions and equations that we find particularly in mathematics and sciences. So I hope that this is elaborate for now. Let's catch up in our next video where we're going to look at the concept of logarithms and some of the laws which are going to be applied in that particular case, just similarly like the one that we have looked at. So that is it for now, guys. Bye. God bless you.